What's up, ladies and gentlemen? Chris with CNC for Newbies here. Wanted to go live and show you guys some macro writing. So let me share my screen here. Let's see, share screen. We'll share the entire screen. Let's see here. All right, there we go. We're going to go ahead and share that screen. Let me see there. We'll make that big like that. You guys can see my StreamYard over here. This is my UCCNC. UCCNC has changed a little bit from your guys's. As you can see, I have the ATC version, where I started creating I started creating my ATC page and letting everything kind of hop in, hop out by the click of buttons and everything. A little bit more user friendly than say using 2115. So in any event, one of the things that I wanted to go over was macro writing. And people are slightly confused as to what this button does or what these buttons do. And all of this stuff is related to different macros in the UCCNC software. So you can actually find those macros. If you go down here into your File Explorer, your main directory, so click local disks, UCCNC, and if you go into UCCNC, you will find profiles. If you go into profiles, you will see macro folders. Now, it is very important that you guys find the profile name that you're using for your macros. So in my case, this is just a demo platform, but I can go in and I can load up a 4896 rack and pinion ball screw Z profile. And whenever I create that profile, it will create a macro folder. If you go into these macro folders, this is the default. These are all different setups for what the buttons on the main screen, like this button is this macro. This is M3, which turns the spindle on clockwise. This little line of code says execute.do spin clockwise, parenthesis, I think that's semicolon. All right. So that's that setup. 4 is spindle on counterclockwise. So here you can see execute.do spin counterclockwise. Okay. And this is all language for UCCNC. And you can find that language in various places, and you can find these macro numbers in various places. This is the M5, which turns your spindle off. It just says execute stop spin. Okay. So that is actually linked to this button as an off function. Okay. Some of the guys have been asking me to program park places for them. That's this button and this button. For you Gerbil guys, this is akin to using your G28 or G30 positions, kind of. So in any event, you have to know where this macro is attached to. So the easy way to find that is go to configuration, go to general settings, go to edit screen. Over here, you will see this edit screen or screen editor. And if you hold shift and click run, it'll take you back to that screen. And I can click on this button, and this button will tell me everything that I need. It tells me the picture that's used. It tells me how many layers the button is, or where in the layer platform it is, and what it's calling for on that button. So this is button number 114. Okay, so we go here. Let's see. Picture number 4. So we can go to images. Picture number 4 is the up is default spindle clockwise. The down is spindle clockwise. Okay, so it has an up and a down function. And if it's up, it's going to be clockwise on. If it's down, it's clockwise off. So it operates an M3 macro and an M5 macro depending on functionality. Okay, so once again, the way to get to this is general settings, edit screen, click it. When it comes up, hit shift and pick where you want to go. At any time, you can go through any of this screen, and as long as you're hitting shift, the buttons will function correctly. If you don't hit shift, you will select that button. So this button right here, we click on it. All right, our identifier. Let me see here. I got to get some paper down. And this is okay. We need 196 for button number, and it's picture 73. Okay, so we already have a picture. We're not worried about that, but we are worried about what the button does. Okay, so if we go to configuration and we go to IO triggers and we set, you can find different functionality codes, and you can link those to buttons. You can link those to ports and pins, and then you can also link that to a button. So all of these indicate different button functions. On top of that, if we go to help, this will tell you your versions and everything like that, and what's supported, what controller is supported. Okay, so all of this is very important to know. All right. But then on top of that, if you go to your main directory and you go up, and you will see documentation, and you will see screen functions, user manuals, buttons by numbers. So if we click buttons by numbers and we look at button 196, what does button 196 do? Button 196, tool length measurement, commands a tool length measurement code executed in macro M31. That's this one right here. Remember from our screen editing pop out, we actually saw that it was button number 196 and that it was picture 73. Okay, so there's that. So we know what our button number is, and we know what our macro is. So now we can go back in here, go to profiles, we'll go to default, and we're going to go to macro M31. Oh my goodness, we've got a lot of stuff here, right? Macro M31 is your probing macro. Now, you can set this up for probing in X and Y location and doing Z. So it'll basically move to a set X and Y location and then probe down for you. Okay. These numbers need to be set based on what you want out of your out of your probing macro. So for me, you know, I might put this at, say, I don't know, 5 inches by 5 inches. So it's going to be 5 inches away from my home position. Okay. Our probing, we could leave that at negative 100. It just means that it's going to try and probe down negative 100 inches in my case to actually set that. That's not really what I want to do. I'll set my probing for negative 6 inches. My fast feed rate, I'll probe at 15 inches a minute. It's slow, but it works for me. My slow feed rate, I do it 2 inches a minute. My safe Z, I put at 0 because it goes all the way up to the Z0 for the machine position. My double retract height, I will set that at 0.1. My retract height for second measurement, I'll set that at 0.1 there. Okay. Boolean movement, do move X, Y equals false. And it tells you what this line of code says right here. Okay. This is actually what it says. It's commented out with the double slashes, backslash, and it says it enables XY movement. So if this is labeled as false, it does not do the XY movement. Do dual cycle is labeled true. Do probing for 2 cycles, first with fast and second with slow feed rates. Okay, we're good there. And that's exactly what we want it to do. Okay, the if statement, execute get LED 56, get LED 57, get LED 58. This is a very important part of code right here. This is where the code stops. This is where the explanation begins. Okay. And this basically says those little red LEDs on X, Y, and Z home position side that are right here, these, if they're not activated, then this macro cannot work with this line of code. So this line of code basically says, get me the state of those LEDs. Are they on or are they off? If they're off, we can't do probing. If they're on, we can probe. Okay. A lot of people get this right here. I could make this say whatever I want it to say just by typing in this box right here, this parentheses. And basically, whenever that happens, you're going to see a message box that says whatever this says, and it's going to execute a stop and return function. Okay. So for the most part, everything you need to do is put up here. This is everything that you need. All right. So this will put me an 1/8 inch above my material for my second retract, my first retract, so that it does the second probing. It'll go up almost 1/8 of an inch and then come down at 2 inches a minute. On my probing screen, you know that I like that at 0.050. This one I don't really set. I usually have this at 10 and 2, but whatever. Our double safe Z, that moves the Z axis up to safe Z 0. So it goes all the way up. And then this is how far it will probe. Okay. So at this point, everything's kind of set in this code. If I hit File, Save, and I close that. When I close this UCCNC and reopen it under that profile, that new macro will now take effect. Okay. So now we go back and we want to set our park position. At this point, you can click that button, and wherever your tool is at on the table, it's going to probe down and touch for Z. Okay. All right. Next order of business is the park positions. You've got 1 and 2 here on this screen, but if you go to tools and probe, you actually have 3. Okay. So you can use the MDI here. This is go to 0. This is your homing reference. These are your park positions and everything like that. So you can actually get all 3 of these park positions, or you can get the same first 2 park positions there. All right. All right. So now if we go to configure, general settings, edit screen, hit the shift key, go to the run screen, click on P1. Over here, write down button 193. Okay. If we go to our button 193, buttons by numbers, we can close that. 193. Go to park position 1. Commands the machine to park position 1. Code executed in macro M200. Okay, so that's macro M200. If we go back to our macro folder, remember this is for what profile you're using for your specific machine or your specific setup. So if we click on M200, this is macro 200, and that's linked to button 193. Okay, so if we click that, go to park position 1 macro. All right, so where do we park Z? It parks it at positive 100. Well, our machine doesn't go to positive 100, so we need to change that to 0, or wherever you want your height of your Z to be based on your homing switch. Okay, it's based on your Z homing switch. Double park X and Y. This is the location of X and this is the location of Y in reference to your homing switches. For us, our homing switches are at the front left corner with Z all the way up. So all of our positions in this macro are going to be positive. Okay, positive X and positive Y. And then our Z will be negative because it's moving away from the homing switch down. All right. So let's say I want to set it with Z all the way up at the back of a, I don't know, a new car 4848. The furthest most back position is going to be 50 inches in the X and Y. Okay, so I'm going to put 0 there, and I'm going to put 50 inches there, and I'm going to put 50 inches there. These numbers are based off of your native units that you set your machine up in. So if you set it up in millimeters and you put 50 in here, it's only going to move 50 millimeters. Okay, just be aware of that. Once again, we got this awesome line of code. The get LEDs 56, 57, and 58. Okay, and we know that those are our homing notifications. Message box, everything's good. Okay, this G0, G53, Z plus park Z. Okay, so what this is going to do, hold on 1 second, guys. My dogo just had cancer surgery and was looking at his wounds. Okay. Anyways, this G00 is a rapid move. That means move as fast as the machine can in that axis to our current Z position plus our park Z position. So ours is 0. So if we were G53Z plus park Z, that moves our position to G53Z0. Okay, so it moves it from the original position to our park position. G00 G53X plus X park plus Y plus park Y. Okay, so what that says is whatever our, I shouldn't say current Z. I messed that up. I'm sorry, guys. G53Z is our home position plus park Z. Okay. This one is G53 X home plus park X, Y home plus park Y. Okay. So at this point, this is going to move the machine as fast as it can to a 0 Z and 50 inches X and 50 inches Y. So if I wanted to remove my material after I'm done cutting, I can click this park button. It's going to move the machine all the way back to the backmost limit. And then I can remove my material and I can hit go to 0 and recarve that. Or I can put a tool change position in, or whatever I want to do with this. I can make the machine park in a certain location that's repeatable based off of the homing switches. Okay. Once again, this is for UCCNC. This is a lot like using the G28 and G30 for the Gerbil. Okay. So that's how you get there. Park 1 is M200. Park 2 is M201. Park 3 is M202. Okay. Once we're done there, click Save, Close. Now we can verify. Okay, everything's good. Here's my park position 2 macro. Set up 50, 50, 100. Okay. All right. Maybe this one I want to park position for material change. So I'll save this one, save. And then I'm going to go back and I'll fix go to park position 1. And I want that for a manual tool change position. Okay. So I'll set that as home position. Let's go. This goes to the home position. Okay. So this one's where I'll change my tools. This one's where I'll change my material. Okay. So this third one, you could put that for whatever. Okay. So now with my park positions and my M31 probing, I can use my park position 1 and my probing button on the main screen to do a quick tool change. So I can click P1. It's going to go to the home position. It's going to then stop. I'll be able to put my tool in, and then I can hit my Z probe and it will be able to probe down. And then I can hit go to 0 and it'll go right back over to my last known XY and my new Z0. And that's what you can do. That's how you can use macros to speed up your tool changes. You can make macros do a lot of really cool stuff. If we go into macros, let's see, Oh, went into easy. Okay. So this setup, let's go into 15. Here we go. Profiles, ATC. This is macros for ATC tool change. You can actually create a bunch of different macros for your tool change. Okay. Most of the macros will tell you right up top what they do, what they're for, and the destructor macro and the constructor macro. This is go to safe Z. You know, you can tell it to go to safe Z. Most of this stuff is part of the kernel, which is the writing of the actual software. But go to 0 with the safe Z. So this actually, when you hit your go to 0, it moves it up to a safe Z, then goes to the 0 position in the work coordinates for that work offset, like G54, and goes from there. So as you click through these, be very careful, because some of this stuff you can really mess up. Okay. Just be fully aware. This is your mist. This is your flood coolant macro. This is to turn those off. So like these three here are your spindle. This is a generic automatic tool changer code. So these would be the X and Y positions. It only has one port, so it would use for a lot of the Chinese spindles, you could actually use one regulator, or I'm sorry, a five port two-way switch. You would use one port to access the clamp and the dust, and then you would use the other port to access the air seal if it has it, or the return spring, or whatever. So you could get away with that, and you basically connect a relay to whatever breakout board. So if you have a UC100, you could use pin 6 for activating the relay to turn the air regulator off and on, or the air solenoid, and that will provide air to the regulators. So you could do a very simple, easy automatic tool changer setup with that. These would be all of your positions for the tool change forks, or the tool change position. So it'll go over to these based on what tool you have listed in the tool right here. So you could put like T1 enter, and that would load T1, right? So the macro knows that tool 1 is in the 50 inches, 10 inches. So 50X, 10Y. It goes up to a safe Z. Then it comes down to a tool release. And then it comes down to a tool pickup. These, you just basically, your safe Z is whatever you want for clearance. I typically keep my safe Z at 0, which is the home position. I then tool release. I would release like, I don't know, an 1/8 inch above this. That way it gives the air chuck enough time to turn back on if you have it set. So this would be, like if I was going to set this, this would be chuck open port. It would be chuck open port 1, and it would be pin 1. And that would be the DB25 pin 1 or the Gecko pin 6. Both of them are the same. Okay. Then let's say I have my tool rack at the back. I could say for the 4896, that's 101 inches. And, or I'm sorry, let's say that that's 10 inches over from homing switch, and that's 101 inches to the back. And 2, let's say that's 20 inches, or tool 2, 20 inches and 101. Let's call that one 30 inches and 101. Then I can actually delete these. If I wanted, I can keep them there. It's not going to reference it unless you reference that tool number. This I'll put at 0. This, mine would probably be like right now, mine's -3.215. And this one is, -3.817. Okay, so this is all the information here. Okay. All this is just actually telling you what it's doing. It's getting the current machine coordinates. It's stopping the spindle and moving it up to a safe Z. It's moving to the old tool position. So whatever the current tool number is, if it was tool number 1, it's going to go over to tool number 1 fork, which would be 10 inches, 101 inches. Okay. And it's going to drop the tool. So it'll open up the port and pin to give 5 volts to the relay, and that will open the pneumatic valve. It waits 100 milliseconds and closes, or 1000 milliseconds, which is 1 second, and it closes. And then it moves up to safe Z. So as that opens, it stays open for 1 second. As it's down at the 3.215, it then lets the tool drop out. It comes back up to safe Z, but the air is turned off to it. Okay. So that's the drop tool, the move to new tool position, whatever new tool you're putting in there. If it's X2, it's going to go over to the X and Y position for tool 2. It's going to pick up the new tool. The new tool pickup, okay. Clear port and pin. So that closes the chuck. Okay. So this is the one thing. This sets it open and then it closes. This one clears it and closes it. Okay. So right now, this has to be extended unless you can get over to the new tool in 1 second. So you got to go up, over, down for 1 second, and then it's going to go down and wait 1 second, and then it's going to clamp. You may need to increase this to 3 seconds or 10 seconds, whatever the speed of your setup is. For me, I actually have a secondary set of code here where it drops the tool, it shuts off the regulator or the solenoid, and then moves over to the new position, moves down, has a set point, and turns on the solenoid, allowing it to reopen, and then it goes down, clamps the tool, and turns it off so that the clamp operates. And then that's pretty much it. So an automatic tool changer really is not that hard. The difficulty comes in the safety of it. Right now, a CNC for Newbies machine is open loop. So it just has steppers on it with open loop drivers. And if you miss a step, you're now not going to hit this position. Okay. So you want to make sure that you have a lot of safety features built in whenever you build a automatic tool changer. Because a lot of things can go wrong, whether it be dropping a tool on the ground, releasing it somewhere on the table before it's supposed to, not being in the right position to clamp it and stuff like that. And all of that stuff is set by these macros and how you want it to interact. For me, I want to say there's 22 different macros right now for my automatic tool changer. And the reason being is there's a verification for spindle on off, and then it goes to a PLC that has to give a feedback loop that, hey, it's off. Okay. And a lot of that's done with relays and things like that. Okay. So that's your introduction to changing different macros. Make sure you save them, and whenever you save them, test them before you do a live cut or anything like that. Your best friends are going to be these two buttons and this button here on your run page. A lot of people don't set those, but really should. All right. With that being said, I'm going to bid you guys adieu. Later.